Let's calculate the standard deviation of a normal distribution. So when we deal with normal distributions, we are dealing with the normal distribution curve, which means we need mean, standard deviation, right? And we deal with the z-score formula because this is going to allow us to find whatever we need in our normal distribution. So remember that the z-score formula means we have the z-score equals the data value minus the mean all over the standard deviation. Sometimes I think it's easier to talk about these with words rather than just the symbols. But z equals x minus mu all over sigma. Let's play. For a normal distribution, we know that z is negative 1.7, x is 58, and the mean is 64. Find the standard deviation rounded to the nearest hundredths. Okay, so what do we know? Well, we've got z, we've got x, and we've got mu. And I know the formula is z equals x minus mu all over sigma. So let's plug in our values. Negative 1.7 equals 58 minus 64 over sigma. Whew, okay, well, I can simplify in the numerator because 58 minus 64 is negative 6. So I have negative 1.7 equals negative 6 over sigma. Fractions are never fun to play with. So let's go ahead and multiply both sides by sigma to get rid of the fraction. So on the right side, those sigmas are going to go away. And I'm left with negative 6 equals negative 1.7 sigma. Now, at this point, sigma is basically a variable, okay? So we want to isolate the variable by dividing, because if you're multiplying by sigma, right, that means the opposite of multiplication is division. So we're going to divide both sides by a negative 1.7. So sigma equals negative, and a negative is positive, and it leads me to a 3.53 rounded to the nearest hundredths. All right, let's do another. Let's do another one. You score an 85 on a test where the mean was 77. If you scored 2.4 standard deviations above the mean, what is the standard deviation round to the nearest hundredth? Right. Now, when you have a word problem, it might be easiest to identify what you know first. So you scored an 85. So x is 85. The mean was 77. So mu equals 77. And you scored 2.4 standard deviations above the mean. So z equals 2.4. Because remember, the z-score tells you how many standard deviations you are from the mean, and above or below will tell you positive or negative. So we're trying to find the standard deviation. Okay, so our formula, z equals x minus mu all over sigma. Let's plug in what we know. Z is 2.4. X is 85. Mu is 77. Sigma is unknown. And we know solving equations, you got to do the same thing to both sides. Well, before I get into any of that, I'm going to go ahead and simplify in the numerator because 85 minus 77 is 8. So I got 2.4 equals 8 over sigma. So now I can go ahead and multiply both sides by sigma. Right, we're going to get rid of the fraction. So 8 equals 2.4 sigma. And then divide both sides by 2.4 to isolate the variable sigma. And 8 divided by 2.4 is 3.33. So rounded to the nearest hundredth. So that would be my standard deviation. So manipulating equations is definitely the key to finding the standard deviation in the normal distribution with the z-score formula.